Kiran, there will be no session tomorrow, but the next session will be on the next week. All right. All right. So far we have discussed about various functions in Pig related to querying the data. And when we were discussing Pig, we also said that Pig is very flexible, right? So, so in case you are not able to get something done using existing functions, you might have to customize. Or there is some business logic you want to run, and which is, of course, will not be there in Pig Latin. So if there is some business logic which you want to run and which is not there in Pig already, or there is some particular function which for which there is no library in Pig, you can use these extensibility features such as calling external functions, creating your own UDF. So we'll go into that detail now. All right. So if there is a function of Java which you want to call in your Pig Latin script, you can use that very simply. Like here we have said, you can see. So what we are trying to do here is there is a function called toHexString as part of Java package. This one we are trying to call this function. Okay, and then this function takes an integer which is a hex which is a integer and converts it into a hexadecimal number. Okay, so let's say we are trying to convert a number into a hexadecimal number, and we don't have a library for the same in Pig. To do that, you can simply call you create an alias for that function, and then you can call that function as if it's an internal function of Pig. See that? Divs equals to load. So divs equals to load NYSE daily, and over that we have run for each statement calling hex function. All right. The only thing you might feel strange about is that we had to cast it here. Even if we did not try to cast, meaning convert the volume into integer, it will try to do it by itself. Okay. Or we could do like integer while loading itself. That means our volume is integer by default, and then we do not have to cast it. All right. So this is where you are calling your function called toHexString. So this function is this function is a static function, so you can make a call like this. All right. Now, if you have your own function, if you have your own jar and you want to call that function like this one, and you want to call your function as if it's a part of Pig Latin script. You want to call your function inside a for each, inside normally. So in those cases, you can basically define in the similar manner the way we had defined earlier. Just that you'll have to first create an instance of the class. So let's say you have currency converter. So you first call the currency converter for these two arguments, okay, which means you are basically creating a convert instance of your class, as if you are creating, you calling a constructor of the class, and after that you can run the convert function on all the arguments. This kind of syntax is good if your function it is not static. So what is the difference between the two? If you are calling a function which is non-static, you always have to instantiate the class, right? So if there is, let's say, box class, and inside that uh, there is some open function inside box. So to call the open function inside the box, you have to first create an instance of box and then call the open function on that. But if the function is static, meaning it's class level, not object level, then you don't have to create an object. You can simply call it on on a integer directly. You don't have to create an instance. All right. So here we are creating an instance, and afterwards we're calling that function on each of the arguments, just as if it's an internal function. Sounds good to you? Now there is a question from Leonid. As part of, let me open the text editor. As part of pig script, does the register function execute right away or get written into instruction script that get executed dump? Okay. So register function gets registered right away. Okay, because if you try to call a method or something, it will give an error immediately. Okay, good question, very good question. Okay, so that even if in case of pig you are trying to say call, let's say you are trying to call convert on exchange, okay, but if there is no such column called exchange, it will give the error immediately. The statement will give an error immediate. It will not wait for the dump to be called. All right, let's say you type here exchange one, right? So you'll give an error immediately. Similarly, in case there is no convert function or the convert function is invalid, it will give an error immediately. Okay, will not execute the function. It will just inspect the function whether function is suitable. Is function taking a one argument, two arguments, and whatnot. All right. So those kind of checks it will take care quickly here. Okay. Good. Very good question again. And in a similar way, the way we are calling Java, you can also call the functions from Python. Okay. So how do you call a function from Python? If you have a Py class, Py, .py is a file name. So production.py is a file name. It contains multiple functions. Okay. In case of Python, you don't need to create a class or anything. You can just list down all the functions. You can just list down for all the function definition in the production.py, and you can simply register that py, and this file has to be locally on the local file system. Same is the case of acme.jar. Okay, and we can say that using Jython as bball. Okay, so we are saying that load production.py, which is your local program, and create an object called bball, which you can call at any point of time. So now you can say that we are calling function called production. There is a production function, or maybe let's say produce. Okay, that will make more sense to you. Let's say there is a produce function inside production.py. You can basically call the produce function directly from bball object. Okay, so now you do not have to rely totally upon pig You can quickly customize, you can quickly create new functions using Python or Java if you are expert at it. In case that the same thing is not available as part of the core pig. Okay, so that gives you a immense flexibility and immense confidence that my work will get done. We will not get stuck with pig because of these reasons. Okay, now you could download this project and then file export and then copy your exported jar onto the server. Okay, so you can take a look at this code. I will just show you how does it look like. So if you have to create your own UDF is user defined function. Okay, then you can use this kind of a project, this kind of example to get it done. Okay, I'll show you this. So this is Hive. Similar to Hive, similar to Pig, there will be Hive also. Okay, let me try to show you the. Let me just close all of these. All right. So inside Pig UDF, you can see that there is a package called Pig UDF, and under Upper, you will see that there is a class called Upper. We are trying to create a UDF user-defined function called Upper, as if it's a internal function. So every function, whenever you are trying to create a function called upper, you have to create a class. Please note that for each function you have to create a class, and inside class you have to define a method with exact name as exec. No matter what you name your function, this has to be the same way. Why? Because you are extending eval function, and in this function, in this class, you have to extend this exec function. Okay, so whenever user is making a call to upper function, your exec will be called. So when we say for each my data set upper and then we give a variable name, then this exec function is going to get called. All right, and what do we get inside it? We get it as a tuple. Okay, we'll get it as a tuple. In case there is a map, you are passing a map, you can say map here. You can say things like map. Okay, so you can say that there is a backend map execution engine, and there is no, not this one. Okay, let me just try to. So we can say arg dot apache dot pig dot data. So we have data bag, for example. Okay, so you can use data bag, not map, and there will be map somewhere. Default tuple is there, and internal map is there. You see. All right, all right. You can use these. Okay. So you can use this, but the difference is that when you are creating an exec function, you need to define it, I think, tuple only. Okay. All right. Now in this, what you have to do is, in case tuple is null or tuple size is 0, which means there are no records, and we are trying to pass a null to it, then it should return null. In case there is no element, as in the 0th element is null, we'll just take it and then it'll return. Okay, so what we are trying to do is, in case out of the full tuple we are only converting the first value of the tuple to uppercase. Okay, to uppercase. Now you can export it and then copy to the server. Okay, you can export it as a jar, give it a name, and then okay, and then you can export it, and afterwards you copy it to the server. Let me open the terminal. Okay, okay, let me increase the font. All right, let me copy whatever I have done just now. Its name was, I think its name was Big Test, and we are copying it to student still, and Hadoop 1 dot no big data dot com colon ascii. All right. So now let me SSH there. Okay. So there we are. Now next thing we are trying to do is so we run the pig, and what was the name of our class? The name of the file which we had created is register pig dash test dot jar. Okay, so it is registered. Let me. So if you give an error like this, wrong name, it would give an error quickly, uh, and it is right now it is successful in registering our class. Okay. The next thing we can do is we basically go to HDFS this particular folder, and there you have this nice file called xyza. Let me check what is there inside. Let me show you what is there inside. So here we are talking to HDFS. When we say cd giri as giri, we are talking to HDFS, and in this these are the files, and this particular file has lowercase letters. Okay. Now if you load this file and try to print the data, okay, then it will be lowercase. But here what we have done is we are iterating over all the lines in A. We are iterating over all the lines in A and generating the uppercase. Okay. All right. Now if you B, dump B. Now everything will get uppercased by the use of big Latin, by the use of our extended function, this function. By default, pig takes the HDFS file system. If you are saying pig minus x local, then every file reference, every time you try to refer to a file, then it will local to a local file system. By default, if you run pig without any arguments, anytime you try to refer to a file, say ls, cd, load, every time it will be HDFS. That makes sense, Kiran. I was trying to answer Kiran's question. Now you can see that it has converted it to uppercase. Okay. Do you want to make some changes or should I move forward? All right. So I'm moving forward. So the way we created PigUDF was pretty straightforward. We created a class called upper. Please note that we have created a class called upper, and that's what we are using everywhere. Okay. This one, you see, this is the one which we created. So it looks like a function inside pig, but when we are creating Java thing, it is actually a class containing a function called exec. No matter what is the name of your function, this will always be exec. All right. In the similar manner, you can also create the input output in case you are trying to load a particular file which is not in your which is for which there is no format available in pig. You can create your custom loader using pig. The way you have HBase catalog, you have pig catalog, the same way you can create your own catalog and load. Okay, I'll show you that. I think we have already discussed that the way we were trying to load JSON structure. In a similar way, we can have an external class that also comes under UDF. Now, the way we were trying to do map reduce, and what was the way? First one was using Java, second one was using Hadoop streaming. Okay, our first one was Hadoop streaming and then Java, the way we had discussed. So we were able to use any of the traditional or any of the legacy code in case of MapReduce, right? Whenever we wanted to use our traditional or our legacy code, which is very specific, and we do not want to convert that into Java, we do not have an understanding of how to alter its behavior. In all those cases, you can simply call the legacy code from within the pig also. The way we called a legacy code, the way we said that this is my mapper, it is some program, this is my reducer, this is some program. In the same way, we can use any of the classically existing legacy code as a function inside pig. Okay, the only thing is this program, whatever we are calling, this program should take the input from standard input, give the output to the standard output, exactly the way our SED does. SED takes input from the standard input and gives out the output to the standard output. Okay, so in those cases you could use pig stream. Okay, let's imagine that you have a file called hidiv.pl which was written in Perl. Okay, you want to run your data through this program called Perl. It takes the data as an input command line as well as command line argument. So from command line argument you provide all the options and the data you provide through standard input. Okay, now you can stream your data, you can run your data through hidiv.pl. It'll basically do a translation from one form to another, and that's what the pig streaming is all about. So you can see that, let's say we have got one div which is basically nothing but NYSE dividends loaded. Afterwards, you're streaming this divs list through a program called hidiv, and whatever is the result, you are again parsing it and telling that the first column is exchange symbol, date, and dividends. Okay, again, whatever output hidiv.pl is giving should be tab separated, otherwise we'll have to say using this as the separator. Okay, so this will become as if this program is run, whatever this program generated saved into a file, and then we are saying load this data as this. Okay, so basically this file again will be executed on all the nodes on which the data is there. Okay, so it's fairly distributed, it's not running locally, right? And will take this will also take care of copying it onto all the nodes by mentioning that ship it to all the nodes. Okay, if your program does not exist on all the nodes and also take some arguments, you could take it to a next level. You define your function and give the full command in the backcode. Okay, that means whenever hd will be called, hidiv.pl will be called with these arguments. Okay, and then you say ship. Okay, this command requires shipping this hidiv.pl to the to the to the all the servers, and that's what this function is. So every time you call hd, now from now onwards, internally when you say dump, it will execute all of this. Okay, after it has shipped and copied this file onto that node. Okay, so now, now you can go to your usual business like load the data and then stream data through this function, and it will be executed. And whatever data, whatever is the result given out by this function, you can consume it like this. Okay, so this is how you call the legacy code, and it works pretty well. Also, please note that it's a backcode. It's not a normal code. The backcode is the one which is just above your tab key on the keyboard generally. Okay, okay. Now, a question from Leonid is this. All right, this is a very interesting question, and can anybody answer this? I want to see that. Okay, anybody? Okay, Deepak says by file extension. So by file extension, Windows does that. Okay, Windows, your statement is correct, Deepak. But on Unix, it doesn't try to use the file extension. Instead, on Unix, it it tries to read the first line of the script. Okay, I'll show you this. Let's say let's say, okay, this is my personal directory. Let's say there is a program called movie renamer. Okay, I have written a movie renamer which basically takes the downloaded movies and clean it up. So you see the first line, you see this first line, this is called a shebang. Okay, it basically tells you, it starts with hash exclamation and then there is a file name. So this bin dash slash bash is the program with which every time I say movie renamer, okay, every time I execute movie renamer, it will execute that particular program which was there in the first line. Okay, and that's how Unix work. For example, let's take yspaces.py. You see that here I have not mentioned shebang at the top, so it will not be possible to run it like without telling that it's a Python code. Okay, let me see if there is, yeah, there is nothing in this. So you can see that even a program like copy sht, it doesn't have an extension, gets executed if we put hash exclamation at the top. All right, Perl has to be installed. Yes, Matthew, you are right. Perl has to be installed on the server. Okay. So basically, in case of Windows, it tries to identify based on the file extension. It on Unix, it tries to find the program name from first line of the script. Okay, extension is not required, and that's true for everything. It's not about pig. It's about the way Unix behaves. All right. So in case you are on Windows, also one more thing. In case you have in this script, the shebang is not mentioned. The first line, which contains the program name, is not existing. So what you can do is you could do things like Python here, or let's say Perl here. So this becomes your command, which will get executed. Okay. And we are shipping this file, meaning copying this file to all the nodes, and in the same folder where this file gets shipped, this command will get executed. Sounds good to all of you? Great. Also, before trying to starting to code, have a look at the piggy bank. Most of the things you want to load or you want to use is already there in piggy bank. It's a humongous repository of things. You can have a look at the piggy bank and understand what all is available to you. Okay, so and you have user documentation, you have piggy bank, and you can go to this particular folder and have a look at what all is available. Okay, not this. Okay, there was a list somewhere which is not, I'm not able to find out. All right, there is somewhere big tools. All right, I think in this itself there was src scripts. Under this there was big packages, org, Apache, big. Yeah. So there are these many, uh, the functions available to us, and these are the common ones. And okay, I think they have reorganized the package. There was somewhere the piggy bank. So it was in repos, trunk, contrib, piggy bank. Oh, just a second. Here there is Java under src, main, Java, org, Apache, pig, piggy bank, evaluation. So these are the various things available here, and but this is not. It's not enough. So this is Java, src, main, Java, org, Apache, pig, piggy bank, pig, piggy bank, and storage. Storage. Okay. Okay. So yeah, I think this is the one. So these are the contributed functions by various people. You can see it's a contributed big bank. And under that you have all functions related to XML, all functions related to util, and there are these other functions here. And related to the storage, if you are trying to load, say for example, CSV Excel storage, if your CSV is in Excel format, you could use that. All right. Similarly, if you have an XML file, you can load using XML loader. And if you have a regular expression based splitter, then you can use this particular this particular loader. All right. And the code is also pretty simple. All it does is it breaks down the input into the multiple fields. That's all right. So okay, so you can have a look at there and use that particular. All right. And the way you basically run this is you download the code, compile it, and then register that compiled piggy bank into your program, and that's it. Okay. Okay, like the way you can do here. So the way we registered our own program, you can also register this newly compiled piggy bank, and then you can start using it. Okay. That was the piggy bank. So this the piggy bank is the one where everybody keeps in contributing. All right. Now pig is I mean, in case of pig, you can also execute the something called for each nested. What exactly is for each nested? Let's take a very simple case of this particular exercise, where what we are trying to do is we are trying to find the count of distinct names in each city. There is first column which contains the city name and second column which contains the name of the person. And we are not trying to find the names, distinct names. We are trying to find count of different names. Okay? In each city. So how would you go about it? Anyone? So here In Bangalore, there is Vivek and Sandeep. In NYC, there is only John. So, what do you suggest here? Anyone? There are multiple ways to do it. Okay, Kiran says that sort by city and sort by the name inside each city. Good. Then in the pig, can you tell me in the pig how will you go about it? There are multiple ways. Okay. Deepak says group by city. Okay. And then we can count. But Deepak, that could have been correct if we only had to count. We want to count the distinct occurrences. We want to count the distinct occurrences. Leonid says that can we do the nested grouping, as in group by city and group by name, and then we can do rest of the things. Good, good. So Leonid, you are actually coming to the point of the for each nested. Right. Okay. All right. Okay. So Kiran says that we can execute distinct cities. Good, good. But But to get the distinct executed, we need to convert the values of each group into a data set on which the distinct can be applied. Right now, distinct is when you say group, all these elements will become part of your bag on which you cannot directly apply distinct. But that is how we will go about, Kiran, with a minor syntax change. Good, very good. Deepak says yes, in this case, duplicates will also be counted. Correct. Kiran says then group by names first, where city equals to first query output. Good. Let me just put some more. Then group by names where city equals to first query output. Okay. Okay. Good. And assign each column to variable and then for each to check for unique names. Interesting. Assign each column to a variable, okay, then for each to check for unique name. Okay. So in case of for each, it will be very difficult to basically find the unique name because it's not like a usual iterator. For each is like saying go over the columns, go over the records, pick only these columns and optionally apply a function to all the column values, just like select statement. Right? So for each is more like a select statement. Good, very good points. All right, all right. The my other approach could be before I jump into for each nested. My other approach would be I group by both the columns. Okay, let's say my data is basically having city and name. Let's say this is my data type, or I can say load file as this. Okay, now this data which I've just loaded, it contains city and the name of the person. What I can do here is I can say grouped equals to Like group data by city, comma name. Okay, I can say that group data by city and name, right? And then I could remove, I can do a for each, okay? Or I can basically also do things like distinct, dis, distinct data, and I can say, yeah, this is good enough. So this will be basically give me only those columns where these are distinct, and then I can do the usual group by and count. Okay, but sometimes it is not. It's quite difficult to get it done. In these cases, you can use a for each nested, and for each nested basically convert the list of values into the data set on which other for each or other group by or distinct can be applied. For example, here we'll load people as city and name, then group people by first column. Now we have all the values as as basically a map, right? Now if you put curly brackets here, that map will be available as a data set to other commands like distinct, generate, and for each and group by and whatnot. So inside a for each you can have another for each. All right, so this is called for each nested. Now, this is a very interesting question, and this is something where pig would stand apart. Uh, I mean, will be standing out from your Hive. Hive is a lot normal SQL. We will discuss that later. But these are the things because of pig. Because of these things, pig is considered very powerful. Okay, so in our previous case, we were trying to group it by, and then we were able to do a nested. Now let's say you are trying to join two files. You are trying to join two data set. One of them is having a billion record, and other one is having hardly 100 records. Okay, let's take this case. You have one file containing name of person and the country he belongs to or she belongs to. This file would be having a million and a billion entries. Okay, and then you have this small file which just contains a mapping of country and its code. All right, like the ISD code I'm talking about here. So this one will have hardly 100 entry. Now your objective is to convert your main file, the bigger file, into name and the code. Replace country with the code. Okay. Ideally, in case of SQL, you would do a simple join, right? You would do a simple join between these two tables and the result will be great. Now, in case of pig, you can make it better because when you join these two tables, so these two files together, like a normal join, it will involve a lot of work. Okay, because what would happen internally is it will basically try to join based on the key called country and then try to map the values, and effectively there will be a reduce phase because all the values of a key need to be brought together and we need to form the join, right? If pig tries to join this kind of table where one data set is very small and other is very big, it will unnecessarily result in reduce phase because you can do it better. If you had to do same thing using normal Java map reduce, you could avoid reduce phase. Can somebody tell me how could you avoid reduce phase using your classic map reduce? Anybody? Very good. Very good. So now Kiran has got a very valid point. So what Kiran is saying, that first load the country code dataset and then use user defined function to replace the country by code from the country dataset. Brilliant, simply brilliant. What does he mean? You take the second file. Okay, if we had to do the same thing in pig, what I'll do is inside my UDF, I will load this data. Inside my user defined function, I load this data and I'll call it to, let's say, I will call this function called to ISD code. Okay, and then country will be passed. Inside this function, I'll do a static method, as in static method, which will hold even across multiple calls to the same class. Okay, creating sort of a singleton where this data will be loaded exactly once on one node. Okay, but again, Kiran, if you see, this file will get loaded again and again. But yes, your approach is correct. Okay, so we'll basically load the second data set into the memory, and then during the map phase itself we can finish off the translation into the IST code. Correct? So this approach is clear to everyone. We load all of this data into the memory because this is a very small 100 entries only, so hardly few KBs. Okay, so it's okay to load this, and during the map phase where we are reading line by line and just replacing this by checking in the second map quickly, because this is loaded into the memory, so it's not that big a deal to translate it. Brilliant. So everybody is with me in this? Okay. So, but when you have to revert back to all your coding skills and all these kind of skills to opt for optimization, then a language or a tool has partially failed. Therefore, Pig has come up. Pig has come up with a syntax called replicated, meaning you continue your usual work as if you are joining these two datasets and just mark the smaller file as replicated. CC by country. We are joining these two tables. One is persons, other is CC. Pick a column from persons as country and CC as country and join the based on this column. And here is the simple syntax. Okay, when we say replicated, when we mark a particular data set as replicated, it will be copied to all the nodes. Okay, and therefore it will not be having any reduced phases. Is everybody with me in this? Is it clear to you? So these are the optimization steps when we think about pig and how does it optimize things. These are the things which matter. All right. Correct. Leonid's question is, as replicated needs to be next to the set which you replicated. Yes. Okay. If you were joining these two persons and CC and you wanted persons to be replicated, I will keep persons on the last and CC in the first. Okay? Because using replicated has to be the last statement. Leonid's question is, how about a situation where everything both have to be replicated? That kind of scenario is actually hypothetical. Okay, because if both are replicated, what does it mean by join? Join means we are taking two data set, we are trying to find out the column values which are same in both. We are trying to join that, right? So If both have to be replicated, that means both are a small data set, and hence there is no need to worry about running MapReduce. And because if both are smaller, they'll be located on a single node, and and hence you don't need to worry about replicating anything. All right? Yes. So Kiran's question is, okay, okay. So Kiran, here Kiran's question point is, can we explain again? Okay, let me try to explain again. So if you had to join these two tables in a traditional sense, and you realize that the second data set is smaller, first data set is located on hundreds of nodes, while second data set is hardly a KB. Okay, now if you have to do the join, and you basically use the pig's traditional join and specify that join it on this column, internally it will do the map reduce and will try to sort the data, bring the values together, and then do the usual stuff. Now, we could avoid sorting because sorting is a very expensive exercise. Also, we could also avoid transmission of the data which happens due to sorting. Now, how can we do that? Because because if you look at here, if we had to do it using MapReduce, the traditional MapReduce, we'll just copy this data everywhere and load it the way you were explaining, load it into the memory, and inside our map function, we will just replace the values from the main data set with this one, okay, without having to have a reduce phase. To get that same thing done, we will just mark using replicated here, and that's it. We don't have to code or bring out our own strategies. Here, what will be replicated? The second table against which we are marking is using replicated will be replicated. If you had to do persons, you had to replicate persons table, the first one, then you will mention CC first and person second after the comma. Okay. So Matthew is saying, so replicated is for, yes, replicating is for optimization, but it is not really necessary. That's correct. You will get the result even if you do not replicate, but it might take 10 more minutes. Okay. So because whenever we are dealing with big data, the dealing with big data or processing big data is all about optimization game. And optimization matters a lot because when something could be done in a milliseconds time, or maybe maybe 5 seconds time, if it starts taking like 10 minutes, it is quite expensive for us. All right. Okay. So Kiran is saying what exactly is done in the backend. Okay. So first is that the smaller file against which we have mentioned replicated gets copied into what you call distributed cache. Okay, distributed cache is the one which is available on every node as part of MapReduce phase. Whenever you are saying, whenever we are saying that take this file to take this script to all the nodes, like we did just now, using ship. Okay, it gets into distributed cache. Distributed cache is a, a small memory which is available on all the nodes. Okay, so file gets copied into distributed cache. Second, while creating mapper, the file, the smaller file, let's call it S file, smaller file, S file is loaded into the memory as a hash map. Okay, hash map is something like a dictionary which you give the key, it'll give you the value instantaneously. Okay, while running the map function, while running the map function, each while running the match function, every record is looked up in the hash map. Okay, and if found the results will be given out. Okay, that's all. This is what exactly what vaguely happens inside this whole process. Make sense, Kiran? Now, all right. Again, there are few more things which you need to take into account. Is all right. Let me just save this file as what is 16th August, and we call it 16th August 2015, 7 a.m. All right. Now, coming back to this again, there are few more optimization things which Pig provides, because when you deal with distributed computing, it's always about optimization. Okay. Let's say you are trying to join two tables. One is having these tables are are very skewed. What does it mean? There are too many values for some keys, while there are too few keys for some. Let's take a case of let's take a case of our example in the word generation, where we were generating next word, first word, second word, first word, second word, right? So for some of the words like is, am, are, the, there will be too many words following them. While for some, like a person's name, there will be too few words following them. Meaning, the keys where the name is there, name is the key, then there will be too few values. While for While for some of the keys like is, am, are, there will be too many keys, right? So the way we faced challenge earlier when we were trying to use reducer on top of these keys, the values will be too many for some, and therefore the reducer will be overloaded, right? As we discussed earlier again, that when a key has too many values, all the values inevitably go to the same reducer, irrespective of how many reducer you have. If a key is having millions of values, all these values hit the same machine. Okay, therefore skewed data is, or data where there are too many values for a key, is a very big headache, and you have to plan accordingly. You have to come up with the strategies such that the keys are not too many. Okay, so in the cases where you are trying to join two tables where there are too many values for a key as in on the columns which we are trying to join, for some columns there are too many values, for some column, you know, for some column values on which we are joining the two tables. Okay, the when we are joining the two tables on column, if though on those keys on which we are joining, if there are too many values for some and for some of the column keys, there are too many value, too few, and I mean the data is skewed. Okay, in those cases, usual join will be really horrible, because reducer will be overflowed in for some keys, and for some the reducer will be running free. All right. Therefore, pig comes to a rescue here, and internally it does a lot of magic to make it happen. You can simply mark the table, you can simply mark the join as a whole as skewed. Okay, so we are joining two tables, and by city on both the side, and we mark it as skewed. Okay, afterwards it will take care of the skewness of data, and the way internally it will try to form the data, it will try to join will be very different. Okay, all right. So skewedness is a very big problem in case of data. So you have to try it out, and then understand what does it mean by pigs skewed. All right. Next is that you are trying to join two data set which is already sorted. You could have avoided sorting of the data again. Okay. When you are joining two data sets, you could have avoided the sorting of the data again. Most of us would be carrying the impression that sorting a already sorted data does not require much. Okay, is that true? So let me ask the question formally again. Let me ask a question formally again. Sorting the sorted data takes very less time as compared to sorting unsorted data. Is that true? True or false? Anyone? If you are sorting the data which is already sorted, and you are sorting the data which is not yet sorted, which one will take? I mean, will sorting the sorted data will take far less time, or it'll take? Okay. So Kiran says it is the best case times complexity sorting. So Matthew is saying, why would you sort the data that is already sorted? You don't know whether the data is sorted, or pig doesn't know whether the data is sorted or not. You are trying to join two data sets which one of the column is already sorted. Okay, you loaded two files in which the key on which you are trying to join these two files or two data sets, the data is already sorted there. Now, in these cases, pig wouldn't know that it's already sorted, so it will try to sort it again. All right. So question here is, sorting the sorted data takes less time as compared to, very less time as compared to unsorted data, true or false? Okay, and Deepak says, let me just put Deepak's point also, this is very good. All right, no system doesn't know the data is sorted, so it will sort the whole comparison. Correct. So it doesn't take very less time, and okay, and you will be surprised for you'll be surprised, actually I was surprised at least, that it takes a little more time to sort the sorted data. Okay, To sort the sorted data, computers, most of the algorithms take a little more time. Okay, if you look for something called binary search tree, okay, you will understand that when you are creating a binary search tree out of an unsorted out of a sorted data, the tree gets heavily unbalanced and the searching takes forever to get it done. Okay, so therefore sorting the sorted data takes a very less time. It takes almost equal amount of time. Okay, most of these algorithms have solved their problem earlier. When for the first time when these algorithms were written, almost all the algorithm did not work for sorted data. They were very, very slow, so they had to do a little bit of a juggling to fix their problem, to so that the time taken for sorting unsorted or sorting sorted data becomes almost equal. Kiran is saying linear sort will take less time. It is, but linear sort is not an algorithm which we use for any sorting. Or in any sorting function, we cannot have this check that before sorting, please check my data whether it's sorted or not. Okay, so sorting algorithm does not. Although there are these algorithms which are very naive, such as bubble sort and such as other sorts, where where the performance of sorting the sorted data is far better, but we never use those algorithms. Instead, you use things like merge sort and quick sort. There, the performance of sorting the sorted data is almost same as sorting the unsorted data. All right, sorting the sorted data means, let's say, I'll show you what does it mean. Okay, so let's take a case of I'll just let me try to do something. All right, let me try to demo you. Okay, let me try to demo you. This is going to consume a little bit more time, but I'm okay. All right, so you have big.txt here. Let me break it down. Let me break it down to std substitute space with a new line. Good. Let me save this into words. So I converted my file into one word per line. Okay, let's try to run through this one. All right, if you say sort words .txt, it takes some time. Okay, and I can say time on this, and we save it as words sorted.txt. Okay, so it shows you that it has taken around 3 seconds, right? It's taken you around 3 seconds. These are very important tools. The time tool basically gives you the time taken to execute this command. All right, let me see what is there in word sorted. Okay, or let me just say tail. Okay, so the data is say sorted inside it. Now let's try to do something, take it a step further and say things like, we put one more sorted here, sorted again. Let me put it this way. All right, let me run it. This time it has taken around 1.3 seconds. Okay, takes 3.7, but it takes uh, around 1.7 seconds. So still, it has taken a time which is one third of the actual, but it hasn't taken the very less time as opposed to our understandings. Okay, so you can see that though it has taken one third of the time, but it hasn't taken something like 1/100th of the total time. Sorting the sorted data, but again, my expectation was different, and I am corrected that. All right, my expectation was that it will take around 2 to 3 seconds instead of 4 seconds. Here it's taking 4 seconds, and here it's taking around 1.2 seconds. All right. So basically, the point I'm trying to convey is sorting the sorted data also takes time, and it's a reasonable time. It's not here 1.2 seconds is huge. Okay, and and therefore we need to always be careful about sorting the data. If it's already sorted, we should avoid it. If we know this information that our data is already sorted, we should avoid it such that it doesn't sort it again. Okay, so this demo was clear to everyone what I tried to demonstrate to you. In word.txt, we created a lot of words. The length of wc minus l is word.txt, and it is having these many lines, which is 1.1 million lines. Okay, so here what we are trying to do is we are saying sort word.txt, and whatever is the result, save it to this file. Now to compute how much time will it take to run it, I have used a command called time. Okay, so time followed by any other command will give the time taken to execute that particular command. Okay, and that's a very reasonable way of measuring it. So are these commands clear to you what I've tried to do? So this arrow means I'm trying to save the output of sort into this file, and all of this command will be executed by time, and time will count how much time will it take to has it taken to execute these commands. So again, yes. So Matthew's point is yes, but since it's already sorted, then it's a waste of time to sort it again. That's correct. And exactly for the same reason, Pig provides you a keyword called merge instead of sorting it again. Because this information you know it, but Pig doesn't know it. Okay? Is my voice breaking, Matthew and Deepak? All right. Kiran, the voice is not breaking for others, so maybe something wrong with your network. All right, great, great. So therefore, it is always sensible to mark something as merge while joining these two tables. If these two tables, daily and divs, both are sorted by symbol, then there is no point in sorting it again while joining, because internally join is going to sort it. Therefore, you use merge. Okay, and what will happen inside is these two files will be concatenated, and that's all. There'll be no reduce phase. There'll be reduce phase, but yeah, it will not be that intensive. I think I think there'll be no reduce phase actually. I need to see that. I don't think there'll be a reduce phase in this, because when you are merging two data sets, you don't need to worry about No, actually there will be a reduced phase. Reason being that records from the two different tables, even if both the tables are already sorted, will have to we will have to be brought together. Correct. Yes. It'll be little optimized. Pig will try to little optimize it. All right. That was about how to optimize in case your data is already sorted. All right. Now, other than group, there was something called co-group. What people found out that mostly every user is grouping and joining by the same column. If you are trying to join the two tables together and then group by the same column, okay? So internally, if you do it in two steps, first group and then join, what would happen is we would end up sorting the data again twice. Okay, first while joining, other while grouping by the same column. So you can do that in a single step and avoid the hassle by using co-group. Okay, let's say there are two tables, one is called owners and pets, and what we are trying to do is we are trying to join these two tables and then group them together. Okay, so so in this case, you can simply say co-group owners. Instead of saying join, we say co-group owners by animal and pets by animal. So it will not only, so if you see for cat, for Adam and cat has been brought together, okay, and Alice and cat, you can see that, are part of the cat. So basically we joined the two data set together and then we did the grouping. Make sense to you? All right. Now, now is the easier part, which is called union. When you are joining two data sets, we were basically trying to bring the records from multiple data sets together into a single record. When we join, the values from columns from left and columns from right join together and number of columns increase, right? But in case of union, number of columns do not increase, instead number of rows get added. So when we say union A comma B, all the data from A gets concatenated by B. Okay, so C is basically total number of rows from A and total number of rows from B. That is what a union is. All right. Good. Leonid's question is very good. I think I forgot to tell you. Is there a performance increase to the case where you would be joining and grouping separately? Yes. Because so there is definitely a difference uh, between the performances. Co-group is far more efficient. All right. Coming back to the union, so unioning while joining were uh, concatenating the columns from first and columns from second based on a key get together, so total number of columns increase to get summed up. So if first data set had three columns and second had two columns, after the join the total number of columns will become five. But in case of union, we add the rows. Okay. Now, in case you want to impose an schema on the two data sets, then you can say union my A and B on schema. Okay. Now, in case of union, what would happen is that it will try to bring in when you can only do union on schema if you have column names defined. If you do not define column names for A and B, the union schema will not work. Okay, so D, when you are saying union on schema of A and B, what would happen is it A and the result will have three columns, X, Y, and Z. So the values from of X from both the data set A and B will be in the same column, while for y and z there'll be no values from both the sides. You will have more clarity on this here. Take a look at this example. Let's say we have a and b. A contains a11, a12, a21, and a22, and b contains a11, b12, a b21, and b22. Okay, when you join on schema, what happens is resulting is there are three columns, X, Y, and Z. All right, and you take a look at this. We are joining on X. Okay, we're joining on, sorry, I'm extremely sorry. We are doing a union of these two. So it's like, because both of them have a column called X. You see, both of the column has X. So here it'll be like both the values from both the data sets will be together here, while since there is no value for y in case of this data set, this column will be empty, and similar will be this column will be empty, z will be empty in case of data from b, and data from a, and this will be empty in case of data from data in case of data from A, the Z will be empty, and in case of data from B, data from B, Y will be empty. You can see that. So is union on schema clear to you? Union is simply concatenating the values from one to another. Okay, but union schema is, is it clear to everyone? No. What does it mean by union on schema and union? Matthew, Leonid, Deepak. Great, great. All right, I think this diagram helped because theoretically it's very difficult to explain. All right, great. Because in my previous session it took me a long time to explain union schema. All right, great. Now, yes, it's like SQL only. Thank you, Kiran. Now, a little bit quizzing. So, if you're joining A comma B, what is the result? Anybody? In case of pig, we are talking in case of pig, not in case of SQL. Anyone? Yes, you should get an error in case of pig. That's correct. Because pig demands that there has to be a key while joining the two data sets. All right. So in case you have to do a Cartesian product or cross product, the way if you join the two table like this, in case of in case of your SQL, so let's say there is a table called A which has good and bad, and there is a table called B which has got uh, apple and orange. Okay, so if you do join A comma B, automatically the result will be good apple, bad apple, and good orange and bad orange. Okay, so so when you join, traditionally you used to get this beautiful Cartesian product and it was very useful. But in case of pig, since the strategy is different, it doesn't work. Okay, so that is the reason pig came up with something called cross product. Okay, cross means all the records of one data set get together with all the records with the second data set. Effectively, if two data sets are having m and n number of records, the result will be m into n number of records. Okay, so that's what is a cross product. So you can use cross, and then also you can say parallel, and you can, here parallel will make sense because cross product requires reduced page. All right, and like with any other reporting tool, there is a parameter substitution. You can use, say, let's say you are executing a file daily. So instead of every day modifying your pig script, you can put a variable by preceding a dollar in front of it, and then every day you, when you execute this particular command, you can specify a parameter from outside. Okay, now if there are more and more parameters, you can separate out the parameter file separately and put all the parameters in this parameter file and use that parameter file instead of single parameter or multiple parameters. You can simply use a parameter file. That way you would not be modifying daily.pig, and 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 hence you would not have to worry about modifications, because when there are different people who take care of execution and different people who are taking care of daily.pig, then there is a conflict of interest when you are trying to do this. For example, let's say daily.pig is coming from your Git repository or SVN repository, and you are checking it out every day. But the moment you modify it, it will stop checking out. Okay, therefore it makes sense to keep the data and the code separate. Okay, it's important to parameterize it. All right, so that's where the parameter substitution comes into play. Also, you can do the splits. You can split the data sets. So one dataset like WLAG can be split it into multiple lags by using various conditions. It's basically generating multiple datasets based on various criteria. Okay, it doesn't mean that the data in these three lags, when we say split wlog into these three lags, it doesn't mean the data is mutually exclusive. Also, it also doesn't mean that some data from wlog has to be in either of that. Okay, or in other words, a record from wlag can go to the multiple lags like April 1, April 2, April 3, or a record could also be dropped. Okay, that's called splits. Next is that the non-linear execution, meaning in case of pig, our execution started when we typed dump. Our execution was not linear like our normal C program or Java program where things get executed from top to bottom. Here it is bottom up. Also, when we are executing things, pig does a lot of optimization and tries to combine groups, filters, and joining into a single one. Okay, it tries to optimize, because if you try to do for each 10 times, it will not have 10 mappers. Instead, it will have a single mapper. Okay, if you try to do group by the same column multiple times, then it will have only one group by. So it does a lot of clever optimizations because it understands clearly what is it that you are looking for. Okay, so you will notice that I tried it actually a couple of times to have a lot of phases of for each, and it automatically combines those phases into a single one. So it does a lot of things under the hood to optimize your query. All right. So that's pretty much about pig. We will go through the pig Latin and SQL comparison after the break. Okay, let's take a break for 10 minutes and come back at 8:47. All right, back by 8:47 a.m. IST. Break for 10 minutes. All right, I'm back. Should we start now? Great. So Deepak, Kiran, Leonid, and Parmeshwar, should we start? Parmeshwar, are you around? All right. So time and again, people keep on asking that why do we use Piglatin when we have SQL already? SQL, when I say here, I'm referring to tools like Hive, which provide you a full-fledged SQL, which internally gets converted into Piglatin. Sorry, not Piglatin, internally get converted into MapReduce. So the way the pig converts Piglatin into MapReduce. In the same way, Hive converts normal SQL into MapReduce. So they are head-on competitors. So why would you use Piglatin over SQL or vice versa? Okay. So language wise, we try to stuff everything in a single query when we talk about SQL. In SQL, we try to put everything in a single statement. While in Pig Latin, it's a sequence of statement. We try to describe how exactly to process the data. Instead, in using normal SQL, we try to describe what we need as the output, and we do not bother at all about the optimization steps. Okay, because in case of SQL, most of it, there was no need of human intervention for optimization. Optimization was a step, but was done by DBAs by creating indexes and others, but not in the main strategy. All right. Now, in case of Pig Latin, it's a long series of data operation. SQL is structured around answering single question. When we are dealing with Pig Latin, we we basically did it for distributed computing. Okay, the Pig Latin was designed for distributed computing. Okay, I'll just mark it distributed computing. Okay, such as MapReduce and others. While SQL was designed originally for relational databases, so the origin makes a lot of difference in the architecture and in the objectives. Piglatin targets multiple data operation parallel processing, while in SQL, for multiple data operations, the query gets complex. Okay, Piglatin can be used when the schema is incomplete or inconsistent. In case of SQL, you need really well formatted data. Okay, so these are few differences between Piglatin and SQL. The other difference is that Piglatin takes care of provides many optimization steps which are not there yet in SQL or Hive. Okay, so general docs are available at this location. We are using 0.13. There has been one or two more releases, but there is not much of a difference. Okay, and here are the custom load functions. All right, that's pretty much about that's good enough for Pig. All right, if you have any questions, let us know about let us know if you have any questions. Feel free to drop us. All right. Okay, we have good questions here. Let me repeat what. Okay, so Kiran says that Piglatin is like stored procedure where we can use multiple data sets. Okay, okay. All right. You can see it that way. All right. Leonid says that, does that mean that there is more control in Pig Latin than Hive? Yes, that's correct, Leonid. So you have more control on how data gets processed in case of Pig. So Matthew is, I'll just say Matthew. Matthew says that SQL updates the database, but it looks like Pig cannot. Good point. But in case of Hive, when we are talking about, actually, this is about Hive. I did not want to write Hive because we have not started Hive yet. Hive also does not provide a way to update the data. All right. Hive also doesn't have a way of, both are analytics tool. Both give you the read-only access. All right. Good. Good. Excellent. Moving on. Any other questions at this point of time? So the next thing which we are going to discuss is Hive and understand what all is required on Hive. Okay. So this Hive session is going to be a little brief. So do not worry. It is going to be sufficient enough and good enough to get started. I'm assuming that you have a good knowledge about SQL. That should do it. All right. Should we start with Hive? You have no questions? Or am I disconnected? Okay. Matthew, Kiran, Parmeshwar, Leonid, Deepak, should we start with Hive? Awesome. Let's start then. Okay, great. So Hadoop is great as well as Pig is great, but how do you move existing SQL infrastructure? Okay, even though Pig might be a great language to work with, but how would you move lot of SQL which people have written in the organization onto Pig easily? It's not, it cannot be that easily automated, or it cannot be that easily translated. Okay. Second, there are lots of large base of SQL users, database designers, and database administrators who do not know Pig Latin. Okay, so it's very difficult for a new language to get an adoption, and therefore no matter what kind of language it is, it takes a long time to get adoption. Therefore therefore what people did was they decided to write something like a SQL which looks like SQL um, language, and made it work such that it gets converted into MapReduces under the hood. Okay. Next is that When you are writing MapReduce, the problem was that it's quite difficult to come up with a MapReduce logic. Okay, converting every problem into a MapReduce is actually a big challenge, and even the experienced programmers end up taking a lot of time to figure out how can they convert their work into MapReduce. Second, it's a lot of repetitive code. Every time you have to do group by, you have to do the same set of things again and again, and it is very verbose and too much time consuming to compile and run. Therefore, there is a space for a tool like Hive. The value proposition of Hive is most suited for data warehouses, specifically where the data is relatively static. The data that is getting analyzed is relatively static. Okay, and in the situation, Hive is great when you don't require the immediate response. Reason being, since Hive or Pig or any of these strategies are based on MapReduce, which is batch oriented, where there is no hurry of getting things done. Instead, more focus is on reliability. Therefore, it takes its own sweet time to get executed. It takes its own time to execute the map the Hive query. Okay, therefore therefore if you don't require fast response, you are okay to have Pig or Hive, any of them. All right, but if you require fast response, your Hive may not be the answer, neither will be the Pig. Makes it easier to port existing product. If you have a lot of SQL already written, go for SQL instead of rewriting everything. Okay, it provides a SQL dialect called HiveQL, which is exactly like SQL for Oracle. Okay, it now the biggest difference between Pig and Hive is that because Hive works on structured data, which means that we need to create a table having the full description of data type fields. And since we are creating this table in which the data will be loaded, this table need to be persisted. Otherwise, every time you log in, like as when you log in into Pig, well, no matter what data sets you created earlier, they all disappear on next login. In case of Hive, that is not the scenario. If you created a table to represent some data, it will be available forever afterwards. You can delete it, but yeah, it is persisted. It is saved onto the disk. All right, and that what is that storage? That storage is called meta store. Okay, whenever you say create table, or the way we said load data into my dataset in Pig, here you can say create table just like SQL, and on top of this particular file, and then start querying it. Now, and the moment you say create table, this definition get added in a MySQL database, which is called metastore and is stored on only one machine. Okay, that's called metastore. Now, the other value proposition from Hive is that it allows you to query the HDFS and HBase database, as well as querying the HDFS files. All right. The limitations again, it does not provide a record level update, delete, or insert. Though the full table you can revamp, overwrite, or drop, but you cannot say that delete one particular record or insert a particular record. Okay, because full table is like overwriting the full file, meaning creating the new data sets completely, which is possible. But row wise editing or deletion or updation is not possible. Okay, therefore it's not suitable for online transaction processing. OLTP is online transaction processes. Okay, because it's slow, it takes some time to launch, Okay, because of Hadoop being batch oriented, and there is always an overhead of MapReduce job startup time, and it's great when you have to when you have to query a large data set which is being maintained. So Matthew is saying, how can we create, update, or delete from HDFS? So when you have HDFS, right, what if you want to create a record or update a record or delete a record, you might have to use things like HBase. Okay, you might have to use things like HBase, which is a database, which we talk later. All right. Hue is just an interface. Hue basically provides you a UI for which what we are trying to do things from the command line interface. All right. So the architecture of Hive is very, very straightforward. You have Hadoop, and on top of Hadoop, we are running Hive. And what does it mean by Hive is there is a main driver. The main driver is here. Main driver interacts with the metastore. Metastore contains all the definition that this is my table, these are the columns, and that's all. Only the metadata definition is in metastore. Okay, metastore is basically a normal database, the relational database, while the actual data of Hive is in the HDFS. Okay, so the driver is the guy who compiles SQL, converts it into MapReduce. Okay, and this driver can be called from many interfaces, be it command line. If you go to command line and type Hive, then that's a command line interface. And then there is something called Hive web interface. So there is a web interface using which you can execute the commands on Hive. Next is the thrift server. Okay, what is a thrift server? Thrift server is a very good service architecture or service platform when you are building any service, be it any network oriented service, and you want it to be really, really fast, then then thrift service is your answer. I have used thrift service in at least 4 or 5 projects to create a service oriented platform. Okay, so instead of using a proprietary one, thrift service is really useful and extremely fast. So so the design of in today's time, the design of most of the service oriented architectures is that they create a thrift service and they let the end user talk to the thrift service. And what is the thrift service providing you? You basically create interfaces, as in the Java interfaces, not UI. You basically declare that these are the functions our service is providing, and each function is having these arguments, and these are the return values, and all of these functions do something internally to give the results. Okay, and this gets translated into hundreds of languages by thrift. So whether your client, whosoever wants to access your service, is using Perl, whether they are using Python or any other COBOL or any other language, there is a client which gets automatically generated for your service, and your client can use that. Okay, so that's the biggest benefit of using a thrift service, and that is why Hive uses thrift service. Similarly, other softwares like HBase, we'll talk in future, they also use thrift service. All right, now thrift service can be you can interact to thrift service of Hive via JDBC, Java database driver, Java database connectivity. Similarly, you can also talk to thrift service using ODBC. Okay, that means it's a very modular architecture from usability perspective. Now, and Hive, so that means that if you have this beautiful BI tool, be it BERT, be it Talent, be it any other tool, you can easily use that. You can easily use that with the Thrift server. Okay, so you can make your BI tool connect to Thrift service and represent your data beautifully on the dashboard. All right. So, and Hive can be connected, all of these services can be connected through Hive, Cubole, and Karma Sphere and other services. All right, here is the straightforward word count example. Okay, so it's basically, you can see that we loaded the data. We first copied the data to HDFS, and then we loaded the data into this. Okay, into our table. Okay, we loaded the data into a table called docs, and in docs we first splitted the line, did the flatten is equivalent to exploded such that one word per line, and after that we did a group by. This is group by here, you can see, and then we cleaned up the data and represented as counts. Okay, so that's pretty much about how word count example comes in. You could come back, after this session and try this out and try to understand this example again at the end of session. All right, now to get started, in our case you can SSH anywhere or simply go to Hadoop 3. Okay, you can simply go to Hadoop 3 here and log in. You can say student, you can say Hive. All right, or you could go to Hue. Not, this is not the Hue. Doesn't listen. All right, now see, you can see that Hive is started. All right, now ls is not a command in that. Okay, or you could run your Hive query from within the Hue, from within the Hue. Here you can go to H catalog, you can browse your list. These are the various databases that exist. Create your own database and start working on it. You can see that this is one table. This is the one table in my database. All right, so that's how you can connect to the Hive. All right, but when on command line we just did Hive, you could also run Hive like this. If you have just one statement to run and you don't want to interact with Hive, you just want to get your work done and that's it. In those cases, the this query gets executed. Okay, Hive minus e and the query. In case you have put all your SQL statements in a big file, you can get it executed using -f as the argument. All right. The most simple way to execute the query is, let's say, create a table. This is probably the most simple script. So we are creating a table called X with A as the argument, as the column, and then we are saying select star from X. We are saying select star from X. All right, now we can drop the table. This is probably the shortest love story kinds, that there was a table, we created a table, we saw the data and we deleted the data. All right, that's probably the sweetest, smallest query. All right, now so there are these ways to get started with Hive. Probably the easiest one is open Hadoop 3.no big data and then get started with typing Hive. Okay. All right. On the prompt, when you start Hive, you see this prompt. There you can type dfs commands like dfs minus ls. So here you can go and just like pig, we can also execute our dfs commands. We can load a Hive script from within the command prompt. The commands start with dash dash just like SQL. You can use the environment variables like this. Okay, you can use these environment variables like this. Also, if you want to execute local commands, you can put exclamation and execute the Unix commands. Okay, here you can say dfs minus ls and you can execute that. Semicolon is required at the end of the script. Okay. All right. Now there are a few things. So before we jump into the SQL, let's understand the data types. There are basic data types like tiny int, small int, big int, float, double, and decimal. And there are boolean, binary. In case of a string, you have a string, varchar, character, timestamp, datestamp. Now, what you need to understand is why are there so many data types? Why do we require int, tiny int, small int, big int just to represent an integer? While both of most of these, will have the behavior very similar to each other. Okay. For example, Boolean and binary do exactly same thing. Similar is the case with char and varchar. Can anybody tell me why are there so many data types? Any guess? Can anybody make a guess? Why do we have so many data types for? So we have a question from Leonid. Would it be reasonable to go through exercises using Hue? Yes. Okay. You can get your exercises done from within the catalog, from within here. All right. That's not a problem at all. Okay. Leonid says that for optimization purposes, we have different data types. Matthew says to use different amount of memory. Good. Leonid is okay. Leonid's question is different. Okay. Kiran says that to use optimized bytes. All right. All right. Interesting. But the truth is, it's for the compatibility. Okay. Some people might have been working on Oracle. Some people might have been working on my SQL, and some people might be working on Microsoft SQL. So that it is compatible with almost all, they have created almost all the data types from all the databases. Okay, and that these data types are increasing in Hive, so that the end user can just copy paste their SQL and then start working. So the inertia to move to Hive from the traditional query, it becomes easier. Okay, because there's a movement of data to the big data, and the traditional DBAs will have a big hesitation to move to big data because they'll say that the existing queries cannot be executed. Therefore, it makes sense to have these all data types, and that's why in every version you see in the bracket it says char was introduced after 0.1 3, varchar was introduced after 0.12. All right, all right. Okay, so yes, Leonid, you can go ahead for both. For both pig and hive, you can use the web interface, right? The Hue one. And all right, next is that the complex data types from Postgres. This is like Postgres data types where you have arrays. Arrays are the array of values of the single data type. Maps are key and the value. While in case of map, the key can only be the primitive data type, while the value can be anything. In case of structures is like your object or class definition, or structures is like your C structures where you have key and the value. Key is predefined and the value is something you can mm, fit in while defining a structure. Okay, now there is something called union. Union is great if you have multiple kinds of values for a column. For some rows, one column contains integer. For some rows, the same column has to contain a string, and for some columns, it has to contain some boolean value, right? In all those cases where the same column has to behave for different data types, okay, it can be only done using union. Okay, it can be done using union. In union, you can store any of either of the values. For example, while providing authentication, a user or employee will have something called authentication token. This authentication token, if the user is coming from Facebook, his authentication is via Facebook, this authentication token could be string. If it is coming from internal, then it could be integer or it could be email. All right. So you can see that there could be multiple kinds of data types fitting into one using union. All right. So Kiran is saying mostly the Hive data types are looking like C, C++. Yes, they look like C, C++, but they actually come as a composition of Postgres, Oracle, and MySQL and Microsoft SQL. All right. So they have tried to bring it up to a level where it can be conjunction of all the it can be a composition of all the data types from different databases. Now, just like we created Just like we created the folders to work with in HDFS or in our normal life, we create a folder, we can create our own database in the Hive. Okay, creating database in Hive is very simple. You can go here and say create database 11 July. Now the database is created. You can say show databases and you will see that it is there. See that? So you can see in the top one slowly, yeah, you can see 11 July. 20, it should be 25 July. Okay. All right. So this is how you can create the database, and keep that in mind. You keep your own database, and in case you want to display the database in the command prompt, you can use this. You can say, you can see now I can say use 11 July, which I just created. Now the 11 July is in my command prompt. To display, you can use this command prompt variable. All right. You can also delete drop database and you can delete it. Also, it's very similar to SQL. So similar to SQL, we can say things like show tables. Right now there are no tables. Show databases, and there are so many databases. We can say use asgiri, and we can say show tables. You have these tables already, and under this you can say describe a table. It'll describe you clearly, as well as you can say select star from my table and describe formatted and extended. Probably this will be the best syntax to use when you want to see the details of a table. For example, let's say describe formatted tweets underscore raw. You see that? So all of this is, clearly described. All right. Now there are two kinds of table. One is called managed table, other is called internal table. And these are the main things to know about Hive. So data is stored in the file you added. For example, so there are, okay, let me try to format it so to avoid. All right. Now, in case of Hive, there are two main kinds of table. One is called managed, called internal table, and other is called external table. In case of managed, if you delete the table, the data gets deleted. While in external table, if you delete a table, then only the table gets deleted. The actual data on which we are creating this data set, creating this table, does not get deleted. Okay, you will understand it as we describe it further. Okay, and Hive has something called metastore. Whenever we say create database, create this, create that, an entry is made in the metastore. Okay, I'll show you this. And so let's say we go to our MySQL. Okay, so let's say I'm logging into MySQL. You can see show databases. So the MySQL is the meta store for Hive to store just the definition of the tables or database which is being created in Hive. Just now we said create database in Hive. This statement is stored in MySQL. I will show you. If you go here, you say use Hive and show tables. We are inside the MySQL where the metadata is stored. You can see there are these there are these details about various things in the MySQL. This is the meta store. Okay. Now there is so all the tables of Hive are being stored here in this one. Okay. I can't locate. Okay. Here. So here there is something called table TBLS. Yeah, here it is. So you can see TBLS. These are the all tables that gets created in the Hive. See that? These are the all tables that created in the Hive. All right. So basically, the meta store is being stored in MySQL, and meta store is basically what all databases are there, which tables are there, table definition, name of the tables, column partition, etc. Okay, so this is the simple table which we are creating in Hive. We say create table NYSE daily, and these are our columns, and this is my row format. and these fields are terminated by tabs, and location of this data is slash data nysc daily. Okay, so you can see this here like this. Okay, so if you go here and in the Hive right now, we are in Asgiri, let's use 11 July. In Hive right now we created a database called 11 July. You also create your own database in Hive, and you say create my table, and there is our table. So we can say select star from this. It already has data. Okay, it already has data. We can drop that data right away and create it fresh. All right, we can delete this table, delete from. Okay, so I've dropped the table, and let's create this table again. Let me again describe. Here we are saying, here we are saying, this is my table. It has got these many columns, and the data is located in this file. Okay, and the fields are delimited by tab. Okay, so we are essentially creating our table view over this data located at this place. Okay, right now when we deleted this table, this data is deleted. Now we'll have to import again. Okay, we'll have to import again. Now we have created this table again. If you try to do select star from nysc daily 1, okay, there is nothing in it. So Kiran is saying Hive internally uses MySQL database. Yes, it uses something called Metastore, which is configurable, and by default, it is configured to use MySQL. Okay. What happens? You delete the file. If you delete the NYSE daily file, then table will exist, but it will keep on showing you empty records, that there are no records in it. In case you again create the table there, it will start showing you the result. Okay, if you go and just rename this file, this folder, it's actually a folder, not file. NYSE daily is a folder, and in case you rename it and then you try to query NYSE daily, it won't be there, and it will return zero rows. Okay, but if you again recreate it, it will start showing. If you go directly into NYSE daily and modify that file, because that file is tab separated. All right. So, but if you delete this NYSE daily 1, the data under the hood gets deleted. Slash data slash NYSE daily is deleted. I'll show you this. You can have a look at, say, we can say here. All right. So we can say Hadoop fs minus ls slash data. Okay. Under this, you can have a look at NYSE daily. Okay, right now this is not there. See, it is being deleted. Sounds good to you? Yes. So this file, this under the hood file, gets deleted. This is basically a folder, not file. This gets deleted if the table you are dealing with is is managed table. That's correct. That's correct. If had this been table been external and you drop the data, you drop this table, then the under the hood, whatever the file is, it won't get deleted. Okay. All right. Now Kiran is saying, will select star from generate MapReduce program? Yes, select star from something will also generate MapReduce under the hood, just like pick. Okay. Select star doesn't, they have done a minor optimization in recent releases. So if you are doing a select star without any where clause, then it basically hits HDFS and reads the data from there, and does not call MapReduce. Okay, they have done a minor optimizations. All right, does that answer your question, Kiran? All right. Now we have created this table which doesn't have data, and we have our data at this location locally. Okay, let me show you. Locally, as in the local folder. I'm exiting here, and you can see. Okay, I'm sorry. Let me just go to the terminal. Yeah, here this is my local folder. Under Hive folder, you can see that there is a file called nyse daily, and from here I can load the data. I can start Hive here also. Okay, and then we can do things like load data which is local at this path, overwrite into this table called nyse daily 1. Okay, and let me first use the 11 July one, use 11 July, and then we say show tables. So we have this table here. It doesn't have any records. You can see nyse daily. Okay, you can see that. Now let's load the data into this table from this location. I'm saying local here, which means local folder, not HDFS, and overwrite into nyse daily. So it's saying copying the data from local folder to HDFS, and then moving it. Okay. So now if you say select star from nyse daily, and you just execute it nyse daily 1, you will get this result. Sounds good to you? Now you can start executing things like where 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 exchange one equals to nyse and symbol one equals to, say, CVA. You can see now this time when we have put where clause, this time it has started giving us this tracking URL and basically started creating the Hadoop job when we put the where clause. Sounds good to you? Sounds good? All right. Okay. So if you load data from local folder, it basically copies it. If you are copying, doing the data from HDFS, let's say, let me, Okay, so but if you try to skip this local keyword here, then it will search for this file in HDFS and load the data from HDFS. And uh, and in the case when you are loading data from HDFS, what would happen is it will move the data rather than copying the data. And the reason behind it is that already one file is replicated thrice on HDFS. It doesn't make sense to make more copies of the same file. So if you are loading data from HDFS into your Hive, then that file gets moved, not copied. Okay. Also, by default, when you are loading, the data gets loaded based on control A. If you have not defined a separator, it will try Hive will try to think that the data is separated by control A character instead of tab or comma. You can specify that as we have specified earlier. If you skipped terminated by clause here, then it will try to think that the data is in the form of control A, is separated by control A. All right. Okay. So if target table is not partitioned, you omit the partition and data is stored on HDFS. Okay, so there's a question from Kiran. Can't we redirect the output of any file like MR will generate reduce file in HDFS? I don't know what does it mean. Let me try to understand again. Can't we redirect output of any file like MR to generate file in HDFS? Okay, so do you mean to say the output of select star can be saved in HDFS? Is that what you mean? Yeah. So that is very difficult to get done, you know. So like we did just now, what we did just now. Okay, okay, I got your point. I got your point. So basically, what you want to do is the way in case of pig we said store, right? And store the result of a query into the HDFS. That's very much possible here also. Okay, because any table is anyway in the HDFS, right? So if you create a new table in which you are redirecting data from one table to another, that table's data gets saved locally in the HDFS, and hence you can do anything you want. All right, I'll show you that also. Okay, so now question is, where is data located? Data is located at this place. I've already shown. In case you do not specify the table location, data is by default located in this folder location. You can simply go to here, and there all the database or all the tables you create will come here. You can see my database already created, and since we have not left the database definition as such, like this, we have not left it, therefore the data is being created in I mean if so the data is being saved in the in sorry, since we have mentioned the database folder, this HDFS name, like in the definition of the table, therefore the data is being stored in this place. If we had not mentioned this, a table will get created at this location under 11 July. All right, you can try it out creating this table without mentioning this location, and when you try to push data into NYSE daily, this table gets created automatically. All right. Okay. Now saving the data, I think this is going to answer your question, Kiran. So you can say insert overwrite local directory to save the data into local file system. If you want to store in the HDFS, you can say insert overwrite directory and the folder name and then SQL statement. All right. Now, this was our table. What was our table? We defined a table, we defined a location from which it can read the data from. Either we can directly modify this file, this HDFS file on which we have created table, or we can insert the data into the table using the load command, and the file will get updated. Okay, but keep in mind that every time you query the table, every time you say select star from my table where this and that, using MapReduce we are basically reading the data from HDFS. Okay, similarly the way our table is reading HDFS, sometimes we might have to read HBase, so we can also define that our table is of HBase. Okay, so we can create a table on top of HBase, and then we can query our table and hit the under the hood, it will hit the HBase. Okay, now coming back to a new term which is there in Hive, sometimes you want to create partitions. Why? Because if your data is too huge and you are querying very often, you would not want to scan the whole data set. Instead, you would like to scan the smaller chunk. So instead of having the full data in a single file, what you do is you basically sectionize your data. You basically split your data, saying for class equals to 1, put the data in first file, keep the second class's data into second, and so on. For different, you create different buckets to store your data. Okay, and to create a table which is partitioned, which has many partition, you have to say that you have to define the partition using partition by clause in a create table. Okay, partition can happen on multiple columns. You can also add a partition later. You define a table which is having a partition. Every time you insert the data, you also tell which partition does this data belong to. Okay, let's take a case here. Let's take a case here. Let's say we have got two files. One is called, let me get out of this and I'll show you. So I have got two files in Hadoop, Hadoop fs minus ls asgiri/hive. Okay. One file is called, sorry, it is local actually, not in HDFS. So yeah. So here you can see the amp and the amp1. These are the two files. Let's have a look at these two files. One is called the amp. It has got two records, one having name, age, and degree. Okay, these are the three numbers. And similarly, we have got another file. Okay, these are the two sections of our data. For some people, okay, for some of the data is in one file, some of the data is another file. Now what we want to do is we want to create a single table encompassing both of these data sets, a single table having the data from both the table, but still the data will stay separated. In case you query the main table, and you provide a where clause, okay, then with the parameter on which these data is separated, the query will only go to the only one file where the data belongs to. Okay, let me come back to this again. So we have got these two files in which our data is there. Okay, and this is very very common. It's a very common phenomena. If you say, for example, you are running Apache web server, your logs are being generated daily. Okay, so some of the logs are in one file, some of the logs are, so you basically keep on separating the data. Okay, so you create a partition table, you create a partition table based on based on the criteria on which your table is partitioned. All right, so let's try to create a table called employees. So we'll try to create a table called employees, and in the meantime let's try to understand also we are trying to create an employee table with three columns: name, salary, and degree. Okay, and there is fourth column called qualification. Okay, fourth column called qualification, which is not part of the data but which is part of maybe the file name, or maybe it's the basis on which the data is splitted into multiple files. Okay, now you also saying that the data is formatted by comma. Okay, because our data is separated by comma. All right, now here what you see is, if you say describe formatted employees, then it will show you that the employees have been created. After that, let me launch it. Okay. If this, there would be one folder created for this. I'll just drop it and then we'll show you. Okay. Okay. So I'm creating an employees table. So it says it already exists. Let me say drop table employees. Done. Now you can see select star from employees. Nothing is there. Good. Now also let's check if there is some data in the warehouse, or we can say DFS. DFS and this. There is nothing in that folder. Now we can load first file. So here we are saying load my first file, the amp, into employees, and mark the fourth column on which the table is partitioned as 1. Okay, this is what we are saying. We are saying, all right, now you can see select star from employees. So you have the data here. See that? There is a fourth column which you have defined that for all these records qualification is equal to 1. And also let's have a look in HDFS what's going on there. Okay, let's have a look at what exactly is going on there. See, there is a folder created called qualification equals to 1. Under that your original file which you have given has been copied. Okay, so basically it's creating these buckets. So all the data for qualification equals to 1 will keep on going into this folder called qualification equal to 1, and the actual file will be inside that folder. All right, so what exactly are we trying to do? We are trying to visualize how exactly it deals with partitions. Okay, now let's say we are copying another file with different qualification. We are copying another file with different qualification. So what happens this time is we are saying the amp1. Now there will be another folder here. Now you see qualification equals to 2 is another folder, and the amp1 is exactly the file you copied there. Okay, now if you say select star from select star from employees, you will see it as a single table, while the sections of the data, this data from here to here is in one file, and this data from here to here is in another file. All right, from here to here. Make sense to you? Leonid's question is, can you partition the data based on existing column? The answer is no. You cannot partition the data based on existing column. All right. So this is how the partition works. Basically, our single employee table is spread across multiple folders and multiple tables. And this is very important when we deal with tables in Hive. Okay. If you are not creating partition table, good enough, not required. All right. So that's how the partition table behaves. Also, just like SQL, you have alter table statement. You can modify the table, rename the table, change the data type of table columns, and everything. And also, at a later point of time, you can also delete the partitions easily. Okay, you can delete the partitions easily, like we have deleted here. Also, the partitions, here we said that create a partition on qualification equals to 1. Similarly you can also create the partition based on multiple columns. Okay, you could say year equals to this, month equals to this, day equals to this, and load this file. So so it will keep on creating those subfolders and subfolders based on that. All right. So this was about internal table. There is something called external table. External table is exactly like internal table except for one keyword called external. And the difference it brings is this keyword, external keyword, makes, you know, every time you delete this table, the data underlying will never get deleted. For example, in the previous example, whatever we have done, if we say drop table employees, okay, so both the partition will get deleted and the data will disappear. So it says the table no longer exists. You see that? So the data has been deleted. So the underlying folder where it was storing the data, it has been deleted when you drop a table, in case of internal tables. But in case of external tables, if you drop the data, it does not get deleted. And be aware of this fact that every time you delete a table, data gets deleted. Also, if you are loading the data from HDFS, the data gets moved. And if you deleted the table, data gets deleted. Therefore, be very aware. If you do not want the data to be deleted, do not do not create an internal table. Do not create a managed table. Instead, create external table. Whenever you are trying to analyze somebody else's data, always create an external table. There is not much of a difference between internal and external syntax wise. It's only in the deletion where it matters. Also, external table can also have partitions, and also the data of external table can be in places like S3. You can say that my data for external table exists somewhere remotely. Like in this case, in this case, the data is in S3 here. All right. Also, the tables are the external table can also get partitioned, can partition. For example, we are creating these log messages to represent our error logs from servers. Okay, and we are partitioning it by year, month, and day, which means for different years, for different days, we are going to have different files underlying. Now you could, at later point of time, you could also say that you can add partition into this table by mentioning these partitions. Okay, You can say that load this data from load this partition's data from HDFS, load this partition's data from S3. Okay, and then you can, when you query and you put a where clause, that particular data set, if you say where year equals to 2012, then only this particular partition will get queried. There will be no request to this file. Okay, therefore partition can also improve the performance of your query. All right. Leonid's question is, what are the benefits of having internal tables? The only benefits of having internal table is when you delete the data disappears and does not pollute the environment. Okay, if you're creating temporary table for time being and all of that, you should basically create an internal table. But if you are initially, because in case of Hive, most of the time you will be loading data from somewhere else because you're not creating data. So initial tables you should generally create external table. Only the derived tables, say you modified some data, kept it somewhere, and so on. All those tables you can keep managed. All right, makes sense, Leonid? All right. So again, let me recap whatever we talked. Each table has got a location. By default, the table's directory is under this location called app hive warehouse. Again, if either you load the data directly into the table or you load the data into the file directly, it's the same thing. You can override that location by mentioning the location in the create table clause. When you say load data from local files, the data gets copied. If you are loading data from HDFS, the data gets moved, the file gets moved actually. And dropping manage table deletes the data at the location, while dropping the external tables do not get deletes the location. And metadata for each table, no matter what it is, whether create table, create database, everything is in the meta store. Only the metadata, not the actual data. Actual data is in HDFS by default. Or in case of external tables, the metadata, so the actual data can be in a remote system. All right. So that's about the general things about Hive. Rest is that you can have complex statement of select, like select name and salary from a table, or you can give the name, or you can have really complex structures. You could have a hash map which you can access here. Similarly, you can have these formulas which can be operated in a very complex fashion. Also, you can have aggregations like group by and select, and sometimes you can also move the aggregation to the map side if the aggregation doesn't involve any grouping. All right, by setting say, hive map side aggregation dot true. All right. Next is views. Views are representation of a query. I think we can take care of the views in tomorrow's session, in the next week's session. All right. But views are very simply, representing a query. We are saying create view tweets clean and saying this query, right? Which means every time I say select star from tweets clean, it is going to execute this query. Okay, every time you say select star from tweets clean, this query gets executed. All right. All right, so yeah. So on the next week we will go through how to create custom functions. Custom functions are very much like pig, and even execution mechanism is, instead of saying register, it's add jar. And then we will also see few more ways of loading data, and then we will continue with our discussion on to other topics like NoSQL and HBase. All right, so stay tuned, and you can attempt the exercise now, HBase exercise now. Also try to do whatever I have tried to demonstrate to you. Select statements. Okay. Also on this exercise, on this slide, there is an exercise in the last. You can try executing that one. All right. And there is an exercise in the LMS also. Please attempt that one. All right. Great. Thank you very much. Have a great day. All right. Thank you, Leonid. Thank you, Kiran. Thank you, Matthew. Thank you, Deepak. And thank you, Parmeshwar. Bye bye. Have a good day.